Hi, I'm Peterlin, Chief Technology Officer at Luxonis, and today I'll be demonstrating neural inference-controlled crop, zoom, and H.265 encoding created using our DepthAI platform. DepthAI is an embedded vision platform ranging from hardware all the way to an easy-to-use Python and C++ library with support for Windows, macOS, and Linux systems. It features both host-controlled and standalone mode of operation. We offer a variety of hardware which is tailored to quickly integrate into your design, not only as a prototype, but also as a shippable product. Head over to losslessly.com for more information. In its core, DepthAI uses Vision Processing Unit MyriadX from Intel, which offers features such as stereo depth, neural network inference, object tracking, video encoding, warp engine, support for multiple cameras, and many hardware-accelerated vision operations like median and Harris filtering, edge detection, etc. All of the above is possible in a small power footprint of 5 watts on average workload. LuxD and Lux1 are our most popular hardware configurations. LuxD offers stereo vision using 2 onboard global shutter mono cameras with hardware-accelerated stereo depth processing. It also features a 12 megapixel color camera with capability of encoding 4K H.265 encoded video. It was designed to address real-life problems where depth and 3D localization information is of crucial importance. Lux1, on the other hand, is its smaller cousin with all features of LuxD without the stereo depth capabilities. Perfect for tasks that don't require accurate depth information and where neural networks can provide enough context of the scene. In today's demo, I'll showcase a pipeline created using our DepthAI Python library running on a Lux1 device. The pipeline records 4K video using the color camera sensor, resizes it for use with the detection neural network which produces bounding boxes of people. The bounding boxes are then used as a guide to extract the desired zoomed-in 1080p region of interest. This region is then encoded to H.265 format, which can then be either streamed or saved. In the first example, we can see a boulder climbing wall with the climber moving through it horizontally. We will track the climber as he progresses through the path. This 4K footage is used both for selecting the final region of interest as well as detecting people in the scene. Next clip shows additional information, specifically the detected bounding box in light green, center of interest as a red dot, and the 1080p region as an olive rectangle. The final region or action frame is now encoded and in this specific example saved. The application uses very basic filtering techniques, which is why the action frame isn't as smooth as it could be. This can be greatly improved by using better techniques like Kalman filtering. Next example is more stationary and looks better with the used filtering method. In this case, I'm presenting a certain topic while the action is intended to follow the presenter. Use cases can range from classrooms to action sports. Again, we can see the detected bounding box as well as the final action frame. Lastly, we encode the final action frame and save it. This demonstration showed neural inference-controlled crop, zoom, and H.265 encoding. This is just one of many possible applications that can be built using our platform. For more information, visit luxonis.com or contact me via email martin@luxonis.com. Thanks everyone for tuning in, and I'm looking forward to what you'll build with our platform. Please enter your questions using the live chat box or schedule a private meeting with us using the Schedule a Meeting button on my profile.